Hello folks, we are coming to the part 4 video of the exercise 8.2, this is the last part, and we have some questions to answer. So let's check how we go about doing it. The 11th question says that you should find out the coefficient of x raised to say n in the expansion of 1 plus x raised to 2n. You should also find the coefficient of x raised to n in the expansion of 1 plus x raised to 2n minus 1, and we should be able to conclude that this coefficient is twice the coefficient of this. That we should be able to conclude. No problem, we will find it out and we'll see how it is coming up. Let's right away get across finding the coefficient. So for 1 plus x raised to 2n, coefficient of x raised to n. So if you have to find the coefficient of x raised to n, you should look at the x raised to nth term also actually. So that means basically we know it is NCR a raised to n minus r into b raised to r. A being 1, that we can neglect. Here it is 2n, c, r for us, because we are looking out for the nth term, it should be n, right? And then that's how it will become x raised to n. So the coefficient of x raised to n is 2n c n. How we got it? We got it that way. Now we'll think of solving this. How does this come? 2 raised to n factorial by n factorial. 2n minus n is n factorial. What happens if you solve this? This can be written as n factorial into n plus 1, n plus 2, goes on till 2n minus 1, then 2n comes. And here you have n factorial, and this n can be written as 1 into 2 into 3 and so on till n, just for our convenience. We are not able to solve much except for these n's can cancel each other. That's all. It's not much that you can solve. Yes, so let's have it that way. Then we will look for the next, for 1 plus x raised to 2n minus 1. We will look out for the coefficient of x raised to n. It will come to, it will come to the same 2n minus 1 c and n, right. So when we work this out, how will it come? 2n minus 1 factorial by n factorial into the difference. So 2n minus 1 minus n, so that is n minus 1 factorial. So like before, we could have written 2n minus 1 factorial as n factorial into n plus 1 can come, n plus 2 can come, and so on. It can go to 2n minus 2, and last you can get 2n minus 1. And so that this n could have cancelled. And this n minus 1 you could have written as 1, 2, 3 and so on till n minus 2 into n minus 1. Okay. When we compare these two, look at the numerator. Till here it's okay, but this 2 is extra. And denominator is perfectly the same. Perfectly the same. So it's clear that, only that 2 is extra. That coefficient, if we could call this a C1. So every time it's very difficult to call. It's clear that C1 is 2 into C2. Everything into 2 if you do, then it will become C1. In this thing, if you multiply the 2, then it will become C1. It's clear that C1 is 2 times C2. That's exactly what they have asked us. Okay. Then we come to the next problem. In that they say that you look at the expansion of 1 plus x whole raised to m. And there is a certain coefficient which comes to be 6. If that is the case, you should find out what is m. So no problem, a general term. General term, how is it looking? If it's tr plus 1 that we are looking out for, then it will be like m c r, 1 we will not consider, x raised to r. And it's only coefficient that we are looking at, so it's mcr. So it's mcr, which is coming as 6. If they have given us anything, find the positive. So the coefficient of x squared, yes, it's a coefficient of x squared. So it's not a general term. No, it's a coefficient of x squared. So if this is 2, automatically this is also 2, and this will be therefore 3. Yeah, so they have told that that is 6 actually. So therefore MC2 is 6. Then it's a matter of solving, right? So it's m factorial by 2 factorial into m minus 2 factorial becoming 6. 2 factorial of course is 2, and this by formula is m minus 2 factorial times m minus 1 into m, and this is 2 into m minus 2 factorial. So you can have that cut. So here if we open up m squared minus m, and let the 2 go there, 12. Let the 12 come here. M squared minus m minus 12 equal to 0. 12 could split 12 into 1, 3 into 4, 6 into 2. 3 into 4 could be good because you could split this as minus 4m plus 3m minus 12 equal to 0. Then let's work out. M times m minus 4, 3 times m minus 4. So m minus 4 into m plus 3, both the product is 0, either could be 0 or either one. So if this were to be 0, m will be minus 3. If this were to be 0, it would be 4. Because m is a positive integer or something they have said. It's a positive value. So that is why we cannot take this. We have to consider m as 4. Therefore, m equal to 4 is the required value. That's about it, and with this we finish our exercise 8.2. In the next video we are meeting with the miscellaneous exercise. Thank you.